All right, so up to this point, we've been working with matplotlib figures that have a single subplot. So what I wanted to do in this video is start going down the road of, handling multiple subplots. Because again, I think this is where, kind of a lot of the power of matplotlib comes in when you understand it, right? And you can actually generate relatively succinct code for doing some common plotting tasks. So let's take a look at that. I'm going to show you just, really kind of two methods for doing this. Today we're just going to be, or in this video, we're just going to be using the basic PLT subplots that we've used up to this point. And then I will show you in another video a different method called subplot mosaic. And again, I still find myself using both of these just depending on the case and the flexibility that I need. So let's go ahead and get started. So I'm going to import matplotlib.pyplot as plt. And we're going to use NumPy to generate some data. Let me restart this kernel. Apparently I've been running some stuff. There we go. Okay, so let's go ahead and generate some data. I'm going to generate 4 series of data. So I'm going to assume that we have a common set of x values. I'm actually going to use NumPy's arange to generate values that start at negative 5.0. And we'll go all the way up to 5.01 because I want to include 5. So that's why I'm stepping just beyond 5. And then for a range, you give it a start, stop, and a step. Very similar to a range, except we can generate, fractional values here. So I'm going to do a step of 0.1. So what that should give me back is an array of floating point numbers starting at negative 5 and going all the way up to 5. Just perfect. All right. And let's generate some y values. All right, so I'm going to also say, well, y is going to be equal to x squared. Let's make that y1. I'm going to do a y2, which is going to be the sine of x for all of those x values. I'm going to make a y3, which is equal to, let's just make that equal to x, so it'll just be a line. And then let's make a y4, which is going to be equal to y1 plus y2. All right, so just generating some various series. So we've got these 4 series, y1, y2, y3, y4, all based off common x values. And let's say that we wanted to plot all of these on a single plot. All right, so what we had looked at up to this point is we had seen how to use plt.subplots when we had a single thing that we were trying to plot. So what did that look like? If you remember, we did something like fig ax is equal to plt.subplots. All right, and we would say we didn't do really anything, even though it does have this in rows, in columns. When we first were looking at it, we had looked up and seen that we have this fig size argument that we can play with. And then we would do like an ax.plot. And then let's say x. And then y1. And we'll do a plt show. All right, so there's a parabola. All right, I'm going to do a little bit of this cleanup. So we had done like some ax.spines. The right and the top spines, we wanted to set visible equal to false. All right, so that's nice. And then we had done like an ax.set x label equal to x. And then an ax.set y label equal to y. We notice that the vertical axis label, which is y in this case, is rotated. So we had said, well, rotation equals 0. And then we had done a label pad. And I'm just going to say that's equal to 15 this time. All right. So this looks decent, right? So we've got a little bit of machinery built here so we can generate a plot for one of our series. And if we were to change this to say y2, right? So we can generate that sine curve. If I wanted to do this for y3, right, there's our line. And then let's see what y4 looks like. All right, so an interesting curve there. All right, but what if we wanted to put these on, multiple different regions of a single figure? All right, well, we can definitely do that. And if we look, all right, we've got that in rows, in columns thing. So that should be helpful to do this. So let's start going down that road. I'm just going to close up a few of these tabs at the top. All right. So if we use in rows and in columns, right? Hypothetically, let's look at this in rows. So the number of rows or columns of the subplot grid. Okay. So let's just see if we can do 2 of them. So right now this is working, right? So we've just tried this with all of our different Y's, right? That's perfect. It's working great. All right. Let's see what happens as soon. Let's just say if we can make 2. So I want to make 1 row. So it'll essentially have 2 columns of subplots. So we'll say in cols equal to 2. Might go ahead and change my fig size so it doesn't get too compressed. But as soon as I run this, I'm going to get errors. Boom. All right. So, and the errors are interesting. Okay. So it says MP in the array object has no attribute dot plot. And if I look, it's pointing to AX. Okay. So it's saying, well, okay, that seems to be insinuating that this AX thing is a NumPy array. Right? So it says, hey, it has no attribute called plot. And that's exactly what's going on. So let's set this back to 1. And this is what, it drives people a little bit crazy, I think, when they're first kind of learning. It's not that hard. I just think, again, at least for, the things that I have seen where people are like, how do I plot this? And then you put in the, Google or whatnot, you get back a Stack Overflow post. It gives you some code, but it doesn't really tell you why that works. And there's kind of a little thing going on under the hood that I think once people understand, it's like, oh, well, it's not that bad. It's just very subtle. All right, so when we run with just 1 column, right, everything's good. So by default, we've got 1 column, 1 row. Okay, and in this case, I'm explicitly saying in columns is 1. Let's look at this AX thing. All right, if I do the type of this, all right, we'll see it as a matplotlib axis. All right, and interestingly, if I get in the cell below, I can do an AX dot and hit tab, and I can look, and there's that dot plot that we're looking for. Okay, well that's great, right? Well, that's what we were calling, and that's why this works, because we're getting back an axis that is an axis object. And we're calling dot plot on it, which is a defined method. All right. As soon as I take that to 2 columns, everything blows up. Right. It says, hey, all of a sudden that doesn't work anymore. Why not? Well, if I look at the type of it now, it's no longer an axis object. And this makes sense when you think about it, right? Because when we just say 1 column, 1 row, it's just saying, well, there's only going to be 1 axis. Here it is. Here's the axis. But when we say we want 2 of them, right? Well, we're no longer asking for an axis. And what matplotlib is avoiding is making it where the number of arguments that you have on this left-hand side, the equals there, they don't want that to change based on whether, well, I call for 2 columns or 3 columns or 4 columns or whatever. They want the axes or the arguments, the things that are being returned, to be consistent. So instead of returning, a figure and then 2 individual axes, they return this AX object that's no longer an axis. It's a container of axes. All right, let's see that. All right, so when we did that type, we've got, well, it's a NumPy in the array. All right, so the container they're returning is a NumPy array. And if we look at that array, it's a NumPy array of 2 things. Right? So the first item is an axis, the second's another axis. So if I want to get an axis, I need to say, give me back the 0th, right? So that's going to be, we've got a NumPy array. The length of that thing is 2 because we requested 2 columns, so it gave us back a container with 2 axes in it. And the first one, which is going to be the leftmost in this case, is going to be at axis AX0. And then we've got AX1. All right. So it returned to us 2 things. So how does our code need to change? Right. So that call is failing. Right. It says, hey, it's a NumPy array. We just saw that AX is a NumPy array. So we can't call AX anymore. What we need to do is specify exactly what axis we want that to be on. All right, so everywhere that I was referring to AX previously, I'm just saying, hey, well, no, specifically put this on AX 0. Now we're getting Y2 on that leftmost plot. All right, what if we wanted to get Y3, or let's say Y4 on the rightmost plot? Well, you take that code, all right, and now I want to say on AX1, right, let's change that to Y4, we said. All right, so now we've got both of those plotted. All right, now you might say, well, gosh, this is starting to be a little bit tedious, right? So, and that's true. So let's see how we can make this a little bit cleaner, right? Because I mean, ultimately, we're doing a lot of the same stuff, right? We're doing the spines, we're doing the set labels, we're, you know, yeah, setting the X and the Y label the same way for both of them. Okay, so what you could do is you can iterate over these things. So let's just do a real quick refresher here. Let's say that I've got, you know, a list. So let's say that I've got A and B, and then I've got another list. So I'm going to say this is going to be my list 1, and then we've got my list 2, and that's going to be, let's just make that, you know, 1, 2. All right. What if I wanted to loop over these in pairs? Well, we could do something like this: for val1, val2 in zip, my list 1, my list 2. All right, and we could print just with an F string so that we can see exactly what's going on. I'll say val, that should have been val1 right here. There we go. Catching that before it becomes a problem. Val1 equals that, and then we'll say val2 equals that. My list, got to put my underscore in there. All right, so we can iterate over those things in pairs. Well, what if these things were NumPy arrays? Can we do the same thing? So I'm just going to convert them from lists to NumPy arrays, even though these are string values in there. I think it's going to be okay. We're going to find out. It is. All right, so we can iterate over them if they're NumPy arrays. All right, what if one of them's a list and one's a NumPy array? So in this case, my list 1 is just a regular Python list, and then the second one is a NumPy array. Turns out we can iterate over them in the same way. All right. Now, so let's think about this. So if I think about it, we've got 2 columns. So AX is a NumPy array. All right. And if I grab the first one, notice it's got some additional information now that we've set those labels. But the first one's an axis, and then second one's an axis. All right, or index position 0 and 1 are both axes. All right, so we can do something like this, right? So, you know, my plot bars, my plot series, let's say, let's just make an object, a list that has the 2 things that we want to plot. So we want to plot Y2 and Y4. Right? Okay. And then, yeah, that should be good. So remember, AX is going to be a NumPy array with 2 elements because we have incalls is equal to 2. Now I have a series with 2 elements. I want this one to be plotted on the first axis, this one to be plotted on the second axis. So now I could do something like this. I could say for plot series, and then I'm going to do CAX for current axis. In zip, I'm going to zip together that list of series. And then AX, right? So that's going to return elements from that list there, my plot series. And AX is just going to iterate over those axes. Now I can nest this underneath, right? I don't need this one anymore. And instead of plotting it on a specific element of that AX array, I'm just going to plot it on whatever the current axis is for CAX. All right, so in this case, I've got, every time I call CA plot, I'm plotting Y2. I actually want to plot whatever the current value of plot series is in that looping variable. And there we go. All right, so we can then, start to use iteration once we realize that, hey, that thing's just a NumPy array coming back. It makes life a lot easier, right? All right, so let's break it one more time. All right, so in this case, we're looking at, essentially just a row of 2 subplots. Well, what if we have multiple rows, multiple columns? All right, so in this case, we got 4 series. What if we want to create a 2x2 grid of subplots? And then we wanted to, essentially put Y1 in the upper left, Y2 in the upper right, Y3 in the bottom left, and Y4 in the bottom right. All right, so I'm going to leave that one up there. So we would do something like a fig AX equals plt.subplots. And in this case, we want to have in rows set to 2, and then in cols set to 2. And in this case, since we're specifying both in rows and in cols, we could just do a 2, 2, because look at the layout. It expects in rows first, then in columns, so we could just provide 2 and 2. And then we'll go ahead and give it a fig size. Let's do 6 by 6. Might be a little bit tight, but hopefully it will fit on my screen here. All right, and then let's just run this. All right, so we've got our grid 2 by 2. Let's look at AX now. So first off, let's look at the type of it. All right, so again, it is a NumPy array. Let's look at the shape of that NumPy array. All right, so in this case, it is a 2 by 2. Now, I didn't show this explicitly, but if I were to go back to the case where we have 1 by 2, it just gives us a 2-dimensional vector, right? So it's not a matrix, right? So it's a vector. So that's how we were able to grab it with 0 and 1 and get back axes. All right, when we go to 2 by 2, right, when I do ax.shape, now we have both dimensions. So if I wanted to grab the upper left, I need to grab the 0 index in the row and then 0 index in that other axis. Right, so now it's kind of weird because we're talking about NumPy array axes and then matplotlib axes all at the same time. So if you remember a NumPy array, they refer to their dimensions as axis. So the first array dimension is going to be axis 0, and then axis 1 is the second array dimension. All right, so this is going to be grabbing one of those, right? So now we've got kind of this nasty situation where we've got 2 indices in this plot, right? So if we were going to kind of do this long form, let me just copy down some of this. If we wanted to do this in a long fashion, right? So we would have to do something like this. We'll do an ax0 0.plot, and then we'll plot x, and let's say y1, and then we'll do that. All right, let me go ahead and do a plt.show to show you that it's going to put that in that upper left. Let me make this a little bit smaller. Let's do 4 by 4. It's going to be really small. Yeah, really starting to get things good and compressed in here. All right, so see that it's really kind of, it's affecting that upper left. If I'd change this to, 1, 1 everywhere, it's going to be the bottom right that gets generated. All right, so if we were going to do all of this long form, it would be a super tedious thing. So let's actually go through the tedium real quick just to show you what that would look like and motivate the need for looping. All right, so that's going to be y1. Then we would do a copy paste, copy paste, copy paste. All right, so for y2, I want to put that first row, second column. For y3, we want that to be, whoops, the second row, first column. And then for Y4, we want these to be second row, second column. All right, so this works. You can see everything's kind of overlapping. I've got everything really compressed in here. So my labels are kind of getting into this. I'll show you really quickly at the end of this how to fix that. But yeah, this is kind of tedious, right? Because if we end up wanting to make a tweak to any one of these, the ways that we're setting up subplots, we kind of remember to go through and do it 4 times. So let's not do that. So if we've got a matplot or a numpy array, so right now the shape of this thing is 2x2. If we want to flatten that out into a vector so we could use that zip trick that we saw just a little while ago, we can flatten that array. All right, so now if I look at the shape of this thing, it's 4 elements, 1 for each axis. All right, so now what we can do is I can do that same trick. I can say, well, my plot series equals y1, y2, y3, y4. And now I could go through and say, well, for plot series CAX in zip, my series, and then instead of just AX, which that worked previously when we only had 1 row, because remember, it returned a single dimensional, it was just a vector, right? It had 2 dimensions. But now it's returning a matrix, so we've got to make sure that we flatten that. Now we can get rid of all of that code. And we just need to change wherever we've got AX, whatever those positions are. Just change it to CAX, and we'll put our plot series right there. Let's see, I've got to have a colon at the end of my for loop. All right, so that got the job done. All right, so again, once you understand kind of that the type and dimension of what matplotlib returns back as AX is going to be dependent on how you specify your rows and columns, right? You know, it's a lot easier to work with. So in this case, I've got 2, at least, you know, more than 1 row and more than 1 column. Well, it's returning a numpy matrix, and I just kind of, you know, figure out what that dimension is and figure out how to work with it. And just to kind of show you, if I look in subplots, the reason that this is occurring is because the default value for this squeeze parameter is set to true. If we were to look at this, let's see where they've got squeeze, right? So if it's true, it's squeezing out extra dimensions from the array. So if only 1 subplot is constructed, right, it gives you the array. The axis object is a scalar. Otherwise, if it's n by 1 or 1 by m, so multiple rows, multiple columns, it's returning a 1-dimensional numpy array. Otherwise, it's returning 2D. So the reason it's doing this behavior is because that's true. You could set that to false, in which case it always gives you back a 2-dimensional array. Or you can just kind of work with the default. I tend to just work with the default and just kind of understand, oh, if I'm doing more than 1 column, you know, more than 1 column, more than 1 row, it's going to be a matrix, those type of things. But you can get nice, really nice succinct code. All right. The last thing that I'm going to kind of mention in this video, or maybe 2 additional things. So first, one thing that's a little bit of, you know, kind of tedious about this method is that, well, let's fix the second thing first. I'm sorry, I'm going back and forth. First off, let's fix the fact that this thing's all jumbled up. So whenever you have multiple plots, again, once you render them, like in this case, our labels are overlapping. Right, so I've got Y that's in these regions of the plot, especially for, you know, the Y, the vertical axis labels for the rightmost subplots are kind of getting over into the actual plotting regions for the leftmost column of subplots. You could, of course, if you give it a larger figure size, so if I go like the 8 by 8, that will probably smooth things out a good little bit, but you can see that it's still kind of doing that behavior. And again, that's just, kind of, you'd be playing a guessing game to figure that out. Exactly what's the right size, and maybe you don't want the image size so large. So let's go back to like 5 by 5. We have a problem here. So let's see how we can handle that. What you can actually do, and this works at the, so right now, when we're doing things with CAX or AX, we're working on individual subplots. And we saw in a previous video when we were saving a figure, we used a plt, and that kind of handled it at the entire figure level. Another helpful method that again applies at the figure level is it's called subplots adjust. So subplots adjust. And it's got these two parameters, W space and H space. So W space is the width of padding between subplots and H space is the height. So in this case, since that Y label is kind of bleeding over into that left column of subplots, we want to give it some width. So we'll give it some W space and let's just try 0.5. All right, so it kind of gives some buffer between those two. All right, we can add a little bit more if we wanted to. All right. Now notice that it's kind of, you know, shrinking the size of these subplots because we kind of defined this overall figure size and it's trying to shrink things and give you that padding that you want. So definitely this W space and the H space as well, they're interacting with this fig size parameter. So you might have to do a little bit of tuning just to get those just the way you like it. But we can also, because if I look now at this plot, we can also see that our horizontal axis label, especially on that top row, is getting clipped out as well. So let's give it some H space as well. Let's say H space is equal to 0.4. All right, so it's not perfect, but you know, at least we can see, you know, all of our labels are kind of associated with the subplot that they belong to. All right, so that's one way you can get some padding at the subplot level, because a lot of times when you're putting these together, it's going to this maybe bleed a little bit into the other regions. All right, the last thing that's kind of irritating is labeling the title. So if you notice in the previous video when we were working with individual plot, I had set a title, but in this case I'm not, right? And the reason is because okay, well, I'm going through and I'm looping through these things. So the series of things that I want to plot in these axes. And well, gosh, I really need a label. Well, I can't call Y1 because that's an object, right? That's in this case, it's a NumPy array. So what you can do, because the labels of these things need to change as well, right? So like in this upper left, that's Y1 versus X. Upper right is Y2 versus X. So you can change this to a dictionary. All right, so just to show you, I mean, this starts to get a little bit borderline on that, you know, loss of readability. So I might say, well, this is Y1 is going to be my key and the value is going to be my series. All right, and then so let's do Y3. And then let's do Y4. All right. So I've got a string representation in the keys, and then here's the actual thing that I want to plot. And those are those objects that we defined at the beginning. All right. Well, now we got to change this, right? Because when I'm iterating over this, if I just, you know, do this, it's just returning the items, right? Or it's returning the keys, I'm sorry. So when I run this, it's going to, you know, it does something, but that's clearly not the behavior that we want. And why is that? Well, if I'm iterating over my plot series, so for val in, it's actually returning, you know, just the keys. All right, so we need the key and the value. So we need to iterate over the items. All right, so now it's returning the keys with the arrays. Right, and the arrays are what we're going to use. So changes things up just a little bit. And again, this is all just back to iterating over dictionaries, right? So now I'm going to say, well, my dot items, but now everything that it's returning from this is no longer a single thing. It's a key and a value. So plot series right here is actually going to be a tuple. And I'm going to say this is going to be my series label. That's going to be what stores the key. This is going to store the actual array, right? And then we can then use that to do something like cax.set title. and I'll make it an F string. I'll say it's going to be whatever the series label is versus X. And I'm going to go ahead and make that upper. Close that off. All right, so now we got Y1 versus X, Y2, Y3, Y4. And this works perfectly fine. We could give it a little bit more padding. But again, it kind of gets a little bit clunky right here because we got to define this dictionary structure. And then, you know, we lose a little bit of that readability, I think, especially in that line of code. All right, but overall it works. Hopefully this was kind of a good overview of how to work with subplots, and hopefully it's not, you know, hopefully it makes sense, right? Because again, I think that's the big problem that I see. People don't really understand why it's changing on them. In a future video, what we're going to do is look at subplots mosaic, which is just another way of laying out subplots. It has a little bit of additional flexibility if needed. And it can be helpful for this, you know, the readability issue that's caused when we're trying to do this labeling. So we will pick up in a future video looking at subplots mosaic or subplot mosaic.